I'm going to introduce to you CP, the command CP. CP is short for compare. It compares two registers. So you have RD and RS. And it is typically followed immediately by a branch statement that checks to see if, for example, BREQ branches to the label if equal. It branches to the label if the two registers that were compared in the previous statement are equal. Or you are NE to the label if not equal. Let's see here. Let's see here. Let me pull up the instruction set manual. The instruction set manual. Let's see here. Pull that up a little bit. And go down to the instruction description of CP. This instruction performs a compare between two registers, RD and RR. None of the registers are changed. All conditional branches can be used after this instruction. So basically what it does is it takes RD and subtracts from it RR, or RS, and it was what I was using, and updates the status register accordingly without changing the argument registers. So if the zero flag is in the status register is set, then the registers are the same value because RD minus RR is equal to 0 if they are the same. Negative if RR is greater than RD. So you can see that BREQ conditional relative branch tests the 0 flag and branches relatively to the program counter if Z is set. If the 0 flag is set. If the instruction is executed immediately after any of the instructions CP, CPI, sub, or sub-I, the branch will occur only if the unsigned or signed binary number represented in RD was equal to the unsigned or signed binary number represented in RR. This instruction branches relatively to the program counter in either direction, up to 64 lines either direction, or 63 above or 64 below. The label that is used is an address, resolves to an address that is the parameter k in the instruction syntax. So yeah, it jumps to the location that you want it to go to. And BRNE is the opposite. Conditional relative branch tests the zero flag and branches relatively to the program counter if Z is cleared. That means they are not equal. Again, it takes a label as a argument, which branches up to 64 lines previous or 63 lines later than the BRNE command. Now, what does this all mean for the programming assignment? Well, what I'm going to ask you to do is have the flow of the program, have the startup, followed by a loop that checks to see if the knob has moved, changed position. So what you're going to do is have the ADC result interrupt handling routine update two registers if there is a change. So it's going to check two registers to see if there is a change in the result, a difference between the previous result and the newest result. If there is a if the numbers are not the same, update the two registers in the loop. If the position is changed, update the timer period register with the new values. So, let me see if I can do a simple flowchart here. Get ADC result. Compare previous result. Are they the same? Yes. We'll go back up to here. No. Update. Period. Register. And go back to the get ADC result. Does that make it a little bit more clear graphically? What I mean by updating the period register of the timer only if there's a change in the position of the knob. That can be done with the CP and branch not equal or branch equal, depending on your style, which you want, which way you want to go with it. But we will look at this as you move along through the programming process. The sessions after spring break will most likely consist of working sessions where you work on the programming project. I can move around the class asking questions or answering questions and helping you out individually with the programming assignment. Like I said, I will have the assignment posted on Canvas on over the weekend. Let's see here. Any questions about this structure of the program? Yes, I'm going to put the all the instructions in Canvas. Like I said, I'll put all that up over the weekend. So after spring break, please bring your laptops for so you can work on the programming projects in class. Has everybody with a Windows machine been able to download the IDE? You have not? The link? I thought I did. Yeah, if I didn't, I can do that this afternoon. I'll check this afternoon, but it should be in a previous announcement. I'm sorry?
I said I still have to download it. Or
Yeah, it should work fine as long as you have a Windows machine. If you have an Apple machine, you're kind of out of luck on that. You just have to use a regular text editor to generate the program files and then upload them to Canvas so I could check them and give feedback, uh, in the event of a bug or something like that. But when you're programming the, let's see here. When you're programming in a situation like this with a new language or a new processor, I highly recommend having this file. Come on. Having this file available to you using Adobe Reader rather than a web browser. So you can make use of the bookmarks on the right-hand side. The peripherals and their addresses are in section 8. All the peripheral base addresses are here. The addresses that you're going to be using are going to be the ADC 0, so base address 0600, port C 0440, and the real-time counter 0140. The voltage reference you're going to have to set. I described that process on Wednesday. So if you took notes, that information should be in your notes. You can review the lecture on YouTube, of course, as well. So Monday, we're going to have a review session of what we've covered for the semester. Go over some some more. Go over what we've done so far and what will be on the midterm. Midterm will be on Wednesday, and there will be no class next Friday, so you can get a jump start on spring break. But I guess that'll be about it for the day.